this video we're going to look at naming and drawing esters. Esters are important groups of organic compounds and they're found in a wide range of biological systems. They make up vegetable and animal fats and oils. Natural waxes such as beeswax, and a range of natural flavours and odours. They often smell fruity, hence the fruit picture on the first page. So esters have a similar structure as a carboxylic acid, except the hydrogen has been replaced by an alkyl group. So this represents a very simple ester, and you can see there is the ester functional group, the C double bond O with an O. In this particular case, here is the functional group of an ester, C double bond O, O, and in this case, here is the functional group of the ester. This picture is showing a range of different esters and their smells, and you can see that they provide a lot of the fruit fragrances that you can smell. Now let's look at how to name ester. These are a little bit more complicated in their naming than other parts because they are made from an alcohol and a carboxylic acid, and we name accordingly. The first step is to locate the carbonyl group. Now what I'm going to do is I'm going to circle the ester group, that's the ester, and now what we do is within the ester we have the carbonyl, and this is the carbonyl here. That is labelled carbon number 1. That carbonyl group came from the carboxylic acid, which becomes the parent name. So 1, 2, 3. So this becomes propan 08. 08 means it's a salt from a carboxylic acid. Now this section here came from the alcohol group. So there are 1, 2. Notice we number out from the ester functional group. And this one would become ethyl propanoate. Now what we're going to do is to try and name these esters. And this is a bit tricky, so you might need to stop, watch, go back and try again. So the first thing I want you to do is locate the ester functional group, which is there. Now we number from either side of that functional group. This component here came from the carboxylic acid and becomes the parent name. So as there is only one carbon, it is a methanoate. This section here came from the alcohol group. We number out from the ester group, 1, 2. There are 2 carbons, so it's ethyl methanoate. Now let's try another ester. Stop, have a go, watch the answer, and then maybe go back again. This one here is a little bit more complicated, but once again we find the ester group. So there's your ester. The carbonyl group came from the acid. this is the carboxylic acid it came from, which you should recognise as benzoic acid. So this becomes benzoate because it's a salt of carboxylic acid. The alcohol group is here, starting from that oxygen, number outwards, 1, 2, 3. So that would be propyl benzoate. Now let's try another one. Remember, stop and start the video. First step, find the ester functional group. Next step, the carbonyl group comes from the acid. So this came from the carboxylic acid. Numbering from the carbonyl group out, 1, 2, 3, 4. So it was butanoate, salt of the carboxylic acid. This section came from the alcohol. So there's only one, so it's methyl butanoate. Now we're going to have a go at drawing esters. So we always start with the parent chain first, add the ester functional group at the end, and then draw the alcohol component from the single bonded oxygen. Then we add any substituent alkyl groups or any functional groups that are in prefix. So this one's a little bit more complicated. Octanoate. So we're starting with oct. That is the first part. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to put my ester functional group on, double bond O, O. So this was the first carbon for the octanoate. This oxygen, so this is the first carbon from the carboxylic acid, 1, 2, 3, 4, 5, 6, 7, 8. This oxygen comes from the alcohol group. Now, for butyl, 1, 2, 3, 4. Now we number out from the ester, 1, 2, 3, 4. And on carbon number 2 was a methyl group. Now we complete by drawing in our hydrogens so that every carbon has the appropriate number of hydrogen atoms. I'd like you to try drawing these esters. You will need to stop the video and have a go. So ethyl butanoate, so we're starting with the carboxylic acid. It's got 4, 1, 2, 3, 4. Here is the double bond. So that represents carbon 1, 2, 3, and 4. Now the alcohol group is an ethyl. So there's the oxygen, 1, 2, 1, 2. Complete the hydrogens by making sure that every carbon has got 4 hydrogens. The next one is hexyl ethanoate. So the ethanoate component tells us this came from the acid. So 1, 2. Put the double bond I. So this was carbon 1, this was carbon 2. I'm going to complete my hydrogens. Now the rest of the thing, the hexyl, tells us came from the alcohol. So there's the oxygen, which came from the alcohol. 1, 2, 3, 4, 5, 6. So this was carbon 1, 2, 3, 4, 5, 6. Notice we always number out from the ester group. Next one, 3-ethyl pentyl methanoate. So the methanoate is from the carboxylic acid group. There's the carbon number 1. The pentyl came from the alcohol group. So there's the ester functional group. 1, 2, 3, 4, 5. Carbon 1, 2, 3, 4, and 5. On carbon 3 of the alcohol was an ethyl group. 1, 2. Complete by putting in the appropriate number of hydrogens on every carbon. You're going to need quite a bit of practice at this, so please go to the OneNote and do some practice, and we'll do some more practice in class.